Okay, I decided to do a video covering the information in chapters 7 and 8, which are basically loops and nested loops. And I'm doing this for a couple of reasons. One, so you can go back and revisit it, because it tends to give students problems typically. The other is we're under a sort of a weather warning tonight, and I don't know if we're going to meet or not. So I'm going to go ahead and put this up, and regardless if we do meet, you can watch it later. If we don't, you'll have it. So we'll be on track for the next meeting. In any event, loops are essentially a combination of sequence and decision making, or ifs, if you will, conditions. As you can see here, I've got what's typically called a while loop in most languages because you have a while keyword. And what this says is, regardless of what's in the body of the loop, which is delineated by an opening and closing curly brace in C++ and C#, you can remember this by using the name of the loop in the definition. While some condition is true, continue to loop. Conversely, when it becomes false, you end the loop. So this condition here decides whether it will continue to loop or not. Now this is what we call a pre-test loop. What that means is this condition is evaluated before the loop is ever entered, because if x were equal to 5,000, when it did this condition, is x less than 5, well, that would be false. That means that the loop would never get entered into. It would never loop. It would just skip over it and either go to the next section of code or in the program, depending on where it is. All right, that's called a pretest loop. Pre meaning before, right? Let me put a hyphen in there. And, you know, it's a while loop. That's just a keyword. Continue while this condition is true. Okay, it's a pretest. It's looked at here. So it doesn't matter what the value of x is. It may not go into the loop, or it may go into the loop. It just depends because it's tested up front. All right. So let's run that and see what we get here. Compile it. I have a breakpoint there. Excuse my cold. Okay. I don't have anything in the watch window, so I'm going to go ahead and put X in the watch window just so we can watch it. And there it is. It starts off at 0. Now, because it starts at 0 and I want the number of loops displayed, I'm having to add 1 to it because I want to see 1, 2, 3, 4, 5, not 0, 1, 2, 3, 4. Still 5 digits, still 5 iterations of the loop. Just for the reader, it's, you know, that's something you do all the time in programming, especially when you start with arrays and structures that always start at an index value of 0. So just kind of get used to it. You'll see it when we get later on down the line. So I'm going to press F10 to step through here. So I'm outputting for every iteration of the loop. I'm outputting, and I'm going to pop it up in a minute and show it to you. Now X is 4, as you can see down here. Kind of keep track of it. All right, so now it's 5, so that should evaluate as false and end the loop, and it did, and it went down to the next section of code. All right, so let me stop this. All right, I forgot to run the, I'm sorry, I forgot to show you the output. Let me do that real quick. I'll put a break here. Okay, let's run it again. All right, there's the output. Loop number 1, 2, 3, 4, 5. So it looped 5 times. If I were to ask you the ending value of x, it would be 5, even though it started at 0, because it has to get to 5 before it ends. So there we go. All right, let's stop this, and let's pull up the next ditty here. Now this is also a while loop. But if you'll notice, it starts with do, all right, and then the while is at the bottom. It's the same condition. It's just a little different structure. This is called a post-test while loop, all right. What that means is, regardless of the value of x, because it is tested at the bottom, it will always fall into this loop at least one time. And you may need it to do that. It just depends on what you're doing, right? So if I set this value, if I reinitialize this x, which I used up here, so I had to reinitialize it at 0. If I set it to 10, ask yourself, will this go into this loop or not? It will go in there one time because there is no test at the top. It is a post, meaning end, test loop. It will fall into the loop, output this one time, this will evaluate as false, and then we'll exit the loop. All right, let's see what we get here. Run it again, made a few changes. See what we get. All right, so there it is. That was the first loop that went by. So now x is 10. You can see it down here, right? I just added a little line break there. So it fell right in that loop regardless of the value of 10. It could be a gazillion and it wouldn't matter because it's not tested into the bottom, right? So see out, it's just going to have one loop in there, and now it's going to hit this. X is not less than 5. It is 11. There's my little incrementer right there. Don't forget about that. I forgot to tell you about it. My fault. With a while structure, you have to increment the counter if you're using a counter so that at some point it will exit the loop. If you do not do this so that this can be false, you have what's called an infinite loop, and I'll show you how that works in a minute. Since I forgot to do it, I'll spend some time on it. But in any event, this is going to evaluate as false, and it will continue on to so it blew out the loop. Now, let's go back, and let's start with this first one up here, and I'm going to comment this counter out. Right. I think you probably already know where I'm going with this. Now, what that means is X is always going to be what it started with because it's not getting changed in here. All right. So this loop will be a forever loop or an infinite loop, which is not something that you want. So it's typical for students to leave some code out that will actually cause that to exit. So let's run it again, compile it and run it, and see what we get here. Now I've got a breakpoint. Now notice watch X down here. Watch what happens. Nothing will happen to it. It's just going to loop forever. X doesn't change. X is always less than 5 because I commented this line out. See that? It's just going to keep spewing that out if I were to keep running. Loop number 1, 1, 1, 1, ad infinitum. That's called an infinite loop. That's not something you want to have happen. So in a loop, like a while loop, you have to increment or decrement. You can go from high to low. You can say X less than 10, start at 500, and decrement X by 10 each time. Or it doesn't have to be an integer. It can be 3.002. You want to add that to it every time, or you want to subtract some number from it. It's called incrementing and decrementing. Incrementing means you're adding to it. Decrementing means you're subtracting from it. It can also be a sentinel value for those of you who took the logic class, which means you may get input from the user, would you like to continue, yes or no? Depending on what they give you, you'll either continue the loop using a sentinel value, or you'll exit it. Okay? It could be coming from a database like an end of file that might terminate a loop. In case you haven't seen this, and we talked about this in class, I'm pretty sure, but this is what's called a unary operator. This is a post-unary operator. So it's incrementing. This is an incrementing operator. Post-incrementing unary operator means look at this, do what you're going to do, and then increment it by 1. Now, there's also something called a pre-increment operator, all right? And it's a plus plus on the left side. When you use that, excuse me, it will increment X before it evaluates it. It'll still increment it by 1, but it happens before it's evaluated. So that, I mean, that can make a difference big time. I could say minus minus, all right? And that would work. That would subtract 1 from X after it's evaluated. If I come over here and put a minus minus on the left side, again, a unary operator, meaning it only has one operator to operate against, it would subtract 1 from it before it's evaluated. It just depends. Now, you're not limited to integers, and you don't have to use any kind of numbers you want, basically. You don't have to increment or decrement by 1. You can use anything else. If you use something other than 1, though, you'll have to use this shortcut, like if I wanted to add 2 to it, all right? That would take X and increment it by 2 on every pass. I'm just using plus equals. We looked at those. So there's a couple of things to think about. All right, so now we know what an infinite loop is. We know about a pre-test loop and a post-test loop. So let's continue on with the infamous for loop, which I really like. Now, a for loop is by nature always a pre-test loop, okay? Meaning it's always going to evaluate before it goes into it. All right, so let's take a look at this. Let me set this back to 0 here, just for grins. All right, so I'm using Y, and notice that when we get into scope and lifetime of variables, you'll see what I'm doing here. I'm creating this inside the for loop header, which means it's only visible inside this loop. If I try to access Y outside the loop, it won't let me. Now, I can declare this outside the loop and just have nothing in here, and that would be fine. We'll get into that later. I mean, it's just a matter of scope. But in any event, if you want to do it like this, you have the data type, which I'm using an integer, calling it Y, and I'm initializing it to 0. Now, this is section 1 of a 3-section loop header. Okay, notice each one of these sections is separated by a semicolon. This is section 1. That's where you create and initialize the variable, just like you would up here, right? And then you have your logical comparison. Y less than 5. If that's true, you go in here and do whatever is in the loop. Okay. And then this is section 3. I'm incrementing y, the counter of the loop control variable, by 1. That's the shortcut for it. I could say plus equals 1. It doesn't really matter. I could say y equals y plus 1, but most people use this shortcut syntax. And again, I'm adding a 1 to it so that it'll make more sense as far as the number of times you're starting at 0. All right, so now the neat thing about this is once you set this third section up here, you don't have to include any code to increment or decrement or change that loop control variable. It does it for you up here. That's the neat thing about a for loop. Not always what you want to use, but most of the time it'll work just fine. And it has the added benefit you don't have to worry about forgetting the to change it. So, well, here, let me explain to you the way this works. All right, I'm going to run it down to here, and hopefully I can kind of step through and show you some things. Okay. As it's getting ready to enter this loop, let me delete this. And I'm going to put Y in here real quick, add a watch. And you can only add watches when the thing is in debug mode. Now notice it says it's unidentified. Why? Because we're not inside this loop yet. That's what I mean. It's only going to be seen inside this loop. All right, so it's going to do section 1 once at the very beginning when it comes in here. And after that, it will never look at this again until it's finished. And if you had a nested loop, it would look at it again after it completes. But so Y is now, why is it doing that? Oh, I guess I'll declare it. What's going on here? Hang on just a minute. Oh, I'm sorry. My fault. I was in the wrong loop. Now, Y's got some junk in it because it hasn't been identified yet. So let me continue on. I was in the wrong area. All right. So now Y is 0. Okay, so it did section 1. Now it's inside the loop, and it also tested to see if that was less than 5, and it was. If it weren't, it wouldn't even enter the loop. So it's a pretest loop. So now what it said, okay, it passed section 2 here. It passed that conditional test. Initialized it to 0. It compared 0 against 5. Is 0 less than 5? Yes. So it went inside here. Now it's going to output this. Okay, so press F10. It'll come back down. Now it's going to go over here to this section, section 3, and increment it. Now, we'll never go back to section 1. From now on, it's going to be 3, then 2, 3, then 2, 3, then 2, until this is false. At that point, it will exit the loop, blow out of the loop, and that'll be it. All right, so press F10. You'll see Y is about to change, and after Y changes, then it will compare Y to 5 again. This will never happen again, okay? Not in this iteration. So now Y is incremented to 1, it outputs it, comes back over here and commits it again, tests it against 5. Now it's 2, it's still less than 5. 3, still less than 5. 4, still less than 5. I'm looking down here too, by the way. Now it's 5, and it blew out because 5 is not less than 5. They are equal. So it did this, did that, and then exited. Okay. Now, that's basically chapter 7. Let's look at chapter 8. More on the iteration process, or whatever it's called. Let me stop this debugging, and let me pull this up here. All right, we're going to look at nested loops, and a neat way to do that is to look at a grid, okay? This is basically a grid, or a matrix, if you will, and this, you don't have to know any high math to understand this, but I just want to point it out. Just go back to Excel and think of in terms of columns, which are vertical, right? This would be column 0, column 1, column 2, and column 3. So there are 4 columns here, and they are labeled 0 through 3. Now in Excel we use letters, but that's a little different scenario. Still, columns are vertical. And these are your rows here, okay? So this is row 0, row 1, and row 2. So if for every row we need to examine a column, and this is called row major order, by the way, which means your outermost loop is going to start with the row and your innermost loop is going to examine the columns for a given row. Then this cell, for lack of a better word, in Excel, that's the example I'm using, would be at 0, 0. That'd be row 0, column 0, right? And this one would be located at row 0, or XY, if you will, and column 1. This one would be row 0, column 2. We're still on row 0, right? And then here we'd have row 0, column 3. And then we could come down here and look at row 1. Now we've moved down. So now we have row 1, column 0, row 1, column 1, row 1, column 2, row 1, column 3. Again, this would be row 2 if we're starting at 0. And then we got row 2, column 0, row 2, column 1, row 2, column 2, and row 2, column 3. All right, so that's the coordinates if you were looking at it that way. All right, so what we're going to do here is we're going to enter. Tell you what, let's do. Let me change this around a little bit. Let's start off. Oops, I'm going to put in a multi-line comment, I hope, here in a minute. All right. All right, so I've commented that out. We're not going to do that quite yet. Let's just do this. I'm going to set these up where they're fixed. And then we'll do it again where we're getting it from the user. It may be a little easier for you to understand here if I do it that way. So these are nested loops, nested for loops. You could do the same thing with a series of while loops. It's just easier to deal with if you use a for loop. And there's a special property that happens in here. So I'm going to go ahead and make this, let's see, 4 columns, because that's what we have up here. No, excuse me, 3 rows. Let's make it 2, because it has to be less than or equal to, because we got 0, 1, and 2. We don't want it. There is no row 3, so it has to. You could also say less than or equal to 3 here. Excuse me. You could say less than 3, and it would still work. Just depends on how you want to do it. I like going with this, but you could certainly do it either way. All right, and then I'm incrementing I rows. Those are my variables, right? Here's where I'm declaring it. And let's see, we're starting at 1. I wonder why I'm doing that. Yeah. Oh well, I better. If we're starting at 1, I may have to go to 3 here. All right, let's see. Starting at 1 here, invert. Let's go to 5. See what's going on here. Okay, let's see what I get. I don't know if I'm going to get the right number of rows and columns or not. All right, so what we're going to do is we're going to start here, and this will be our rows. All right, and for every row, we need to examine all the columns. So in row major order, your outermost for loop is going to be rows. All right, and then we set up an inner for or an inner loop that's going to examine each column in that row. So for row 0, I'm looking at column 0, 1, 2, and 3, and then I need to move over here for row 1 and look at columns 0, 1, 2, and 3, all right, to sort of do a grid. And I'm going to try to print out these coordinates, assuming I have this correct, and I may not. I'm trying to remember what I did before I changed it. All right, so let's compile it, and hopefully it'll work. Here I'm just outputting my rows and so forth. All right, let's see what we get. I'll go back and add this in a minute where the user can do whatever. All right, so let's delete this. Let's go ahead and put in I rows. Now I'm going to show you the property I was talking about here. All right, I rows not call. F10 sets I rows to 1. This is my condition. So it's going to look at I rows. If it is 1 less than or equal to 3, yes, it is. So then it drops down in here, okay? Now, once you get inside this inner loop, it's going to run until it finishes. This loop goes into suspended animation as long as you're in this inner loop, all right? Keep that in mind. That's important. All right, so now I'm inside this inner loop, and rows stays the same because this is suspended for now. We're inside of this for loop. And you can see that by watching I rows, it doesn't change. See, I column is changing. I screwed this up big time, but anyway, don't worry about that. Should have been less than or equal to 2, I guess. All right, and so there we go. Now this innermost for has ended, so it's going to come back up here and go back and increment I rows. This one is gone now. It's finished. Now we're picking up with this outermost for that was in suspended animation as long as we were in this innermost for loop. So now watch what happens to rows down here. It gets incremented by 1, becomes 2. This is still true, so it drops back down inside, becomes suspended again with I rows at 2 and goes into this innermost for loop, which gets reset. All right, that's another key property here. This gets reset and it repeats. So it's going to go from column 1 to, column whatever. I'll have to play with that later and fix it. That's not the main point anyway. All right, so it's back inside here. It's going to reset iCall to 1 and keep going like this. And then it goes back in increments rows again. Rows becomes 3. So I'm just getting an extra column in a row is what's going to happen here, or an extra 2 columns in rows. And then this gets suspended again. It goes back inside this inner loop, which represents the columns, the vertical columns, and it's going to reset it and go back through it again. All right, so it goes back up here, increments rows. The rows is, again, that was it. It became 4 once this was incremented, and it ended. All right, and you can see that my table's a little off. I got 1, 2, 3, 4, 5, 1, 2, 3, and I should have started with 0. But I mean, that's just a matter of, I still have 4 columns and 3 rows. I just started at 1 instead of 0, which I should not have done. So let's see.